Hey, in this video we're going to look at how to take our geometric sequences that we've been working with and use them in an application. So in this application here, we're looking at growth. We know it's a growth question because it says that the population of the island is growing at a rate of 3% per year. So we're using the same formula that we've been using, which is that UN is equal to U1 R to the n minus 1. But the key thing here is to be able to know what U1 is, what R is, and what N is. All right, so if the population is growing at a rate of 3%, some people are tempted to say that R is 3% or that R is 0.03. It's not, because remember, it's growing. So if the first year it's 15,000, if the first year is 15,000, the next year is going to be 15,000. So that whole thing plus 3% of 15,000. So R is actually, for growth, going to be a whole plus that percent increase. So let's make sure we have that down, because that's a key thing in this topic. R is always going to be 1 plus the percent increase, but that should be converted to a decimal, which means here that R is going to be 1 plus 0.03, and in this case R is equal to 1.03. All right, so once we have that down, U1, much easier. You're looking at the starting number, and in this case the starting number is 1500, so we know what U1 is. But N is harder. N is the position of the term, or whichever, like where that term is. So I hope that makes sense, but if it doesn't, it will in a second. So you may be tempted to say N is 7 years, but it's not. Think about it. If you have, let's make a little side note right here. If you have the start, we know at the start we have our first term. After 1 year, we actually have our second term. After 2 years, we actually have our third term. So basically after 7 years, then the term would not be the 7th term, but check it out. The term is actually 1 more than the year. When the term is 2, the year is 1, because when the term is 1, there is no year, no time has passed. So therefore our 7th term is actually, our 7th year is actually U8. Now, that's a lot to think about. So instead of thinking about having 8 and then subtracting 8 minus 1, we can think of replacing n minus 1 in the formula just with time. So now we don't have to do 8 minus 1 here, which in fact is just 7. We can just put time here. So it's going to be an altered version of the formula where we have UN, or the final amount, is equal to U1 R to the T. So here we have U1, which we already said was 1500. 1500 R, which we already said was 1.03. 1.03 raised to the 7th power. So we're going to work that out in the calculator, and we get 1844.81. But remember that we're dealing with people here. And so after 7 years, we can't have 0.81 of a person. So we have to round. And rounding here is a little tricky because you're thinking of the population growing. And this happening here is not yet a person created. That person has not yet been created. Perhaps someone's pregnant and they're almost ready to give birth, but that person has not yet grown or gone into that population. So after 7 years, we have 1844 people in our island. All right, let's look at an example now in which something is decaying. So it is going down geometrically. Okay, so in this example, we have our fish going down, and we know that it's going down because it says the fish are going extinct. I know it's sad, but we do have to look at this topic as well. So we start off with 1,700 fish, and the species is decreasing at a rate of 5% per year. So thinking about what we said before, when we were growing, our R was 1 plus the percent growth. Now that we are decreasing, our R, and I'll put it over here, our R is 1 minus the percent decrease, but as a decimal, which means that our R is 1 minus 0.05. So R is actually 0.95. Okay, so doing everything we did before, or UN equals U1, that's U1 because that's our starting value, 1,700 times R, we just determined that's 0.95, and we're doing it the easy way this time, raised to the time, so time is 4 years, so we can just raise it to the power of 4. We put that in our calculator and we get 1384.66. Now, here we have the opposite thing when it comes to rounding. The fishes are decreasing. These fishes have not yet died. They're still alive, barely kicking or swimming, and that means that we need to round up in this case. So the fishes have, that last fish has not yet died. There are 1,385 fish. All right, now how long will it take for half the fish to die? I am not going to complete this question, but I am going to start you off. So in order to figure out how long it would take for the fish to die, what we have to do, half the fish to die, what we have to first do is figure out what number is half the fish. Well, we started from 1,700, and half of 1,700 is 850. So we want our final amount, or UN, to be 850. How long will it take us to get to 850? Well, we know our starting number is 1,700, our R value is 0.95, and we don't know the time. That's what we're trying to find out. So that is what we're going to try to solve here. So now we're going to try to solve for an exponent, an unknown exponent. There are 3 ways to solve this. We can either use logarithms, take the log of both sides. If that makes no sense to you, don't worry, that is not the only way. That's one method. The second method, which I'll show you in the next video, is using solver. And the final method is trial and error. Try a number, see if it works. If it's too big, try something smaller. If it's too small, try something in between. And you keep zooming in until you find the answer. So if you are not sure of how to use any of these methods, stay tuned for the next video where I'll show you how to use solver.